Hi guys, so today's lesson is about displacement reactions, so that's your title for today. And I've got a bit of a starter question for you on the slide here, and that question is this: what will happen when copper chloride is dissolved in dilute hydrochloric acid and aluminium is added to it? I've got some options at the bottom of the screen down here. And what I want you to do is I want you to look at those options and jot down your predictions before you move on to the next slide. So let's just go over that again. We've got some copper chloride dissolved in hydrochloric acid, and then we're adding aluminium to that. The aluminium is actually just going to be kitchen foil, aluminium foil that you might have in the kitchen drawer at home. And so your options are, by the way, more than one of these might be true. So note down the letters, the ones that you think will happen. So do you think A, the copper chloride will react with the aluminium? Or B, the copper chloride will react with the acid? C, the aluminium will react with the acid? Or D, oxygen gas will be produced? So pause, have a little think, jot down some letters, and then we'll move on to the next slide. Okay, so forgetting that this is actually going to be on YouTube, so you'll have to pause that yourself. What I want you to do in a moment is I want you to go to the link, which is just here. Unless you've actually opened this as a PowerPoint. If you're watching this on YouTube, you won't be able to click that link. I will pop that link into Classroom for you, so you can pop onto it there. It's the clearest little demo video that I've seen of this particular reaction. If we were in the lab, I would show you this myself. When you're watching this, just ignore the references to Father Christmas. It was obviously uploaded onto YouTube as a suggested Christmas demonstration, but it's great at any time, and it really demonstrates some chemistry that I want to cover in this lesson really well. Start it, if you can, fast forward it to 3 minutes. The first 3 minutes is just talking teachers through how to set this up, and you'll get bored by the time you actually get to the interesting bit if you don't do that. So whiz it forward to 3 minutes and then just watch it from there. And as you're watching it, think about the reactions which are happening and listen to all that this guy on here is Simon Quinnell. He works at the Science Learning Centre in York, is telling you about that reaction. So pause this now, go to that link and have a little look. Okay, so hopefully you've now watched that reaction. And let's go back to the original question at the top there. What will happen when copper chloride is dissolved in dilute hydrochloric acid and aluminium is added? So it's dilute acid because although he used concentrated acid in the experiment, he added that to water, so he made it into dilute acid. Then he added the foil. And let's have a little think about what happens. So the copper chloride didn't, in fact, did it react with the aluminium? Actually, yes, it did react with the aluminium. Let's see if this clicks up here. It's true, that did happen. So that was a displacement reaction. The aluminium, let's pop my cursor on again then. Whoops, let's go back a second. Why not let me do that? Okay, so the aluminium actually replaced the copper and made aluminium chloride. And if he'd shown you the close-up of the flask at the end, you'd have seen bits of copper actually in the flask. The copper chloride, however, didn't react with the acid. When he added the copper chloride to the acid at the beginning, before the aluminium was added, it just dissolved and it formed a nice colourful solution. The aluminium, on the other hand, did react with the acid. That was the fizzing that you saw going on and the bubbles being made, and one of the products of that reaction was not oxygen gas but hydrogen gas. So a gas was produced, but it wasn't oxygen, it was in fact hydrogen. Okay, so we're going to talk a little bit about what a displacement reaction actually is. So a displacement reaction is one where a more reactive metal will replace a less reactive metal from a compound. Don't worry about writing this down just at the moment. I've got another slide in a minute with a pencil which will show you when to write things down, so just stay watching at the moment. So there's magnesium, reasonably reactive metal, magnesium, as we found out last lesson, and if we put that in with some copper sulfate, copper is lower down on the reactivity series, and so the magnesium can displace the copper from the copper sulfate, and we'll end up with magnesium sulfate plus, oops, I don't know if I will move this now, but that should say under there, that should be our copper separately. I'm kind of in the way for that. Okay. Let's look at another example now. So, remembering that this always holds true, a displacement reaction is one where a more reactive metal will replace a less reactive metal from a compound. Let's see what's going to happen here. This time we've got magnesium plus calcium sulfate. And if you can remember back to last lesson, we found out that calcium was in fact more reactive than magnesium. So this time, no reaction will happen because magnesium is less reactive than calcium, so nothing happens this time. Okay, so let's just bring the words up on the slide and then I'll tell you when to pause to write this down, because the pencil there means I would like you to make some notes in your book at this stage. So displacement reactions can occur between a metal and a compound of a different metal. The more reactive metal will displace a less reactive metal from its compounds. Displacement reactions are easily seen where a salt of the less reactive metal is in a solution, and during the reaction what you would actually see is this. You'd see the more reactive metal gradually disappearing as it forms a solution, and the less reactive metal coating the surface of the more reactive metal. Now I have seen it in an exam question where it's asked for you to write down what you would see. So that last little bit there, I would like you to include that in your notes. So pause this now and write down everything that is on this slide. Okay, so we can use the reactivity series to predict if a metal will react with a compound containing a different metal. So I've got some possible reactions over here. So I'm just bringing this pointer back up. And what we're going to do is have a look to see if these reactions will, if any reaction will happen with these combinations. So if we add magnesium to aluminium oxide, let's find magnesium and aluminium in our reactivity series. Well, here's magnesium, and it's higher than aluminium in their reactivity series, so that means magnesium is more reactive than aluminium. So magnesium is able to replace aluminium from aluminium oxide, so there a reaction will happen. Let's see if this will come up. Okay, so now let's have a look at the, let's just bring that one up. So yep, so we've got our magnesium has replaced our aluminium and made magnesium oxide and aluminium. Let's have a look at the next example now, and to predict whether this is in fact going to react, whether magnesium will react with iron chloride, we once again need our reactivity series. Let's see if I can make that come up. There it is. So again, there's magnesium. This time I'm looking for iron, and again, magnesium is above iron in our reactivity series. It's more reactive and therefore it will react with the iron chloride. There we go. So the magnesium has replaced the iron. So we've got magnesium chloride now and iron separately. Time for the next reaction. The next reaction is silver and zinc oxide. So again, we need to look at the reactivity series, and there it is. Let's find silver and zinc this time in our reactivity series. Well, there's zinc. we've got to go all the way down here to silver. So this time our silver is less reactive than the zinc in the compound, the zinc oxide. So this one is in fact not going to react. So there we go. This time there is no reaction whatsoever. Finally, let's move on to copper and gold nitrate. Interesting, I'm not sure that compound would really exist in reality, but if it did, let's have another look at our reactivity series, and there it is. And let's find gold right at the bottom, and copper, which is not very high, but it is above the gold. So in theory, this reaction would take place. And there we go, we get our copper nitrate and gold, with the copper replacing the gold and leaving gold all on its own over here. Okay, so in a minute I'm going to ask you to pause this video again so that you can have a go at doing some of these for yourself, but just listen to these instructions first. So remember that when you are writing equations, the arrow should be in the middle. Your reactants, that's the things you start off with, should always be to the left of that arrow. And then your products, the things you are going to add in, must be to the right of that arrow. If you cannot fit these bits in the left side of the page, write them underneath each other. You can put your plus and write zinc sulfate underneath the magnesium if you need to. Just keep your reactants to the left and your products to the right. And here is something else really important. Please could you leave 2 lines underneath each word equation, because in a minute I'm going to ask you to add symbol equations underneath. So you need to leave space for those when you're writing your word equations now. So pause the video now, copy out the reactants, add the arrow, and you add in the products of each reaction. Okay, so now you need to just check your answers, your products, and tick them with a green pen if you've got them right, or correct them if you haven't got them right. So for the very first one, you should have got magnesium sulfate plus zinc. Your magnesium is more reactive than zinc in our reactivity series, so it will displace the zinc, giving those 2 products. Next, magnesium is also more reactive than copper, so you'll get magnesium sulfate plus copper. And lastly, sodium is more reactive than copper, so you'll get sodium sulfate plus copper in our last reaction. Okay, so now we're going to have a go at adding some symbol equations for our reactions. So I've done the first one for you up here. So here we've got our metal. Here is our metal compound, our zinc sulfate. Now, in order to work out the formulae for your ionic compound, and this is actually in solution, you need to know what the formulae of the different ions or the charge on the different ions are. Because overall, an ionic compound must have no charge. So in this case, I've got, let's just write this at the bottom for you, we've got Zn, 2 plus ions, and then we've got the sulfate ion, and that sulfate ion is actually, altogether is SO4, 2 minus. So there's a 2 minus charge on that sulfite ion. And you can see if you combine those two, then the charges will cancel out. So zinc sulfate is just ZnSO4. Similarly, magnesium, because it's in group 2, loses 2 electrons when it reacts and would form Mg, 2 plus ions. So magnesium sulfate is simply MgSO4 because the charges cancel out. When the metal's on its own, by the way, it's just the metal on its own, and you just need the symbol for that element. So you're going to have a go at working out the other 2 in a moment. You're going to pause this again. but you're going to need to know what the charge is on a copper ion. Incidentally, copper and zinc are both transition metals. You are not expected to know what the charge is on those ions. They are not as straightforward as the group 1 and group 2, group 3 metals, where you know how many outer electrons there are, how many they're going to lose, and therefore can work out the charge on the ion. So they would give you that information in an exam question. But I'm going to tell you now that copper forms copper 2+ ions, just like zinc forms zinc 2+ ions. So that's the information you need there. They're copper 2+. And sodium you should be able to actually work out, but just as a reminder, sodium is in group 1. So it has one outer electron, which it loses when it reacts, forming Na+ ions. So this is kind of our odd one out here, because it's only got a single positive charge, and you will need to think about that when you are writing the third one of these equations. So pause this, have a little go at that now. If you're a little bit confused, maybe do it in pencil so that you can change it if you want to when you move on to the next slide. Okay, so here we go. We've got our first equation here, and we can see we've got Mg plus CuSO4. Again, because copper ions have got a 2+ charge, sulfate ions have got a 2- charge. You just need one of each. So that's CuSO4, and it goes to MgSO4 plus your copper on its own. And the very last one, this is the one that's a little bit more tricky. And we need some balancing numbers going on here as well. So we've got CuSO4 and Na. We'll come back to the number 2 in front there in a moment. Now here is Na2SO4. I'm not sure. There we go. This is Na2SO4 because a sulfate ion, this ion has got a 2- charge. Therefore, we need 2 sodium ions to cancel out the charge. So it's Na2SO4 here. And because we've got 2 sodium atoms here, we need 2 sodiums on this side, hence the number 2 over there. Don't forget plus the Cu on the end. Hope you had a go at that. Don't worry if that was a little bit confusing. That's the more tricky part. Okay, so finally for this lesson today, we need to not only be able to use the reactivity series to predict if certain reactions will happen, to predict if a displacement reaction will happen, but we also need to be able to understand what makes some metals more reactive than others. And we need to be able to explain that in an exam. So let's go back to what happens to metal atoms when they react. Well, let's go to the example of our sodium atom. And remember, sodium is in group 1. If we look here, it just has one electron in its outer shell. So just one in its outer shell. And we know that all atoms just want to have a full outer shell. So when it reacts, it loses that outer electron and becomes a sodium ion. Now, really, what we should have here is some square brackets. Let's see if I can just draw those in. We should have some square brackets. The charge that's written in the middle there, really normally we would put just a symbol in the middle and we'd put that charge on the outside there. So it loses that outer electron, it becomes a sodium ion. So all metals, not just sodium, react by losing electrons. And when they do that, they form a positive ion. So all metals form positive ions. But for some atoms, it's easier for its metal to lose electrons, and the easier it is for a metal to lose electrons, the more reactive it is. So some metals are more reactive than others because for some it is easier for them to lose electrons and form that positive ion.